Hello, this is Prem Kumar 2014, and today I'm gonna illustrate some of the basic concepts of functional modeling in object-oriented programming scenario. So, syllabus we are gonna discuss today are some of the data flow diagrams, specifying some operations, constraints, simple function, object-oriented techniques, modeling techniques like OMTs and methodologies. Example in case of study to demonstrate some methodologies and OMT. There are several modeling terminologies like UML and relationship diagrams, and also we are going to discuss this today. So, starting with the functional modeling, we can understand that what is functional modeling? Okay, I'm going to tell you. The functional modeling tells that how the output is derived from input. Simple. Suppose a state diagram like an oval, and you have to expand that something like a modeling technique. So you have two inputs, and what you do is do some processes, put that process inside the oval, and then sketch a line coming out from oval. That two lines are going inside, which are the inputs, and the oval is the processing, and then we get output. This is functional modeling. That's it. So, a brief of functional modeling is, this tells that how the input will give the output. Simple. And it contains the data flow diagram, which I illustrated, that there is an input and there is processing something oval inside, and then the output is coming. That is the functional modeling diagram. We call that DFD, data flow diagram. Easy. And then specify the results. It is specified the result, but now how the result is obtained and when, like how the operation is going on inside the processes of oval, we don't care. And how will the result come, we don't care. We are just concerned with input, the processing part, not inside that much, only the processing part, what is going on, only the brief, and then the output. That's it. Easy. The diagram do not show the control or object structure information. No information is shown by the object and anything in the diagram. It's just simple input and oval, and output is coming out of it. Simple. Now the kind of functional modeling are spreadsheets, are some of the kind of functional modeling. They have nothing to do, they have just inputs and outputs and the processing part. That easy. How the processing going, when the result came, we are not supposed to do anything with that. We just have to represent our inputs and output criterions. Holy shit. Okay, proceeding to the next one, we have operation in functional modeling. We have several operations in functional modeling. Some of them are mathematical functions, table input outputs, equations, pre-post conditions, decision tables, pseudocodes, and natural languages. Since we have talking about the DFD, what is data flow diagram, it's basically I have categorized in three ways. It shows the functional relation between the values. What? First of all, the DFD shows the functional relation between values. The second thing is this graph shows the flow of data. How the data is flowing in our program is shown by the DFD. That's it. And it contains the processes that transforms our data, like we are doing some addition, a plus b, and which gives the value a plus b. That is, if we are working with a equals to 5 and b equals to 3, then the processing part contains a plus b, and which gives the result 8. So we have changed the previous result of a 5, and and added some 2, like if we add 2 with 5, then we get 7, and we again assign it into the A, and the result is A. So what we have done, we have somehow managed to change the data of A with the help of some processes, and these processes are termed or represented in the DFT. Simple. So now we are going further. We can see some elements of data flow diagrams. So let's discuss about it. Okay, we have got some elements of data flow diagram. I want to discuss it one by one. That we have got some processes transforms the data value. As I have discussed earlier, we added 5 plus 2 equals 7. So the 5 value is upgraded to 7 with the help of plus process. That is, processes transform the data value. Second one is the graph is high level process, and the process may have side effects and non-functional components. Next, the ellipse containing the description of transformation. As I have earlier told you, that 2 lines going inside that ellipse, and there is a process like plus on ellipse representing the status of process, and the multiplication result or the addition result or division else is coming out as an output. So there are some processes we were discussing, and now the data flow. Oops, got some outdated results of antivirus. Okay, leave that. Now the input of another object or process, it represents the intermediate data value with computation. The value is not changed by data flow. When data is flowing over each other, the value is not changed while it's flowing. But when the processes occur, the data manipulation can take place. Easy. Only data flow is the transfer of data. No changes occurring ever in data while flowing. Only changes occur in processes. Okay. Going further, we have some actor and data storage. We are not concerned about that. Now we are talking about data flow. Data flows equals, it means the Boolean value decide the process executed or not. Got it? What is data flow? Data flow is a decision like yes or no. Should it process or not? The plus should be done or not. So just like this, data flow is the Boolean value that decides the process executed or not. Got it? This is shown by dotted lines in the graph of DFT. We can say data flow diagrams. And now we have some computation paths in decision sequences to control issue. The Boolean value that affect whether a process is elevated or not. This is the data flow. Sometimes duplicates the information. Well, we can say sometimes like passing from one to another, it duplicates. Pressing for multiple times, it duplicates the value. You can take it. In dynamic model, it duplicates. Okay. Next one is nested data flow diagram. Well, we can say it is useful in showing high level functionality of a system and its breakdown into smaller functional unit. What data flow diagram does, like we have multiple calculations of plus minus multiplication division and all, and what we have done, we have represented some inputs and processes. We flow those inputs over the lines, and then processes occur in some units and output is transferred to another one flow. So what we do is we splits breakdown splits and break down the high level functionality system into a small units, so that we can achieve the specified we can achieve some specified results. So it's a representation. I don't think there is else is here. Now we are on page number 44. There is an input, process, and output. That's it. Everywhere in data flow diagram is input and output. That's it. Okay, so now we are working with the object modeling technique. Discuss all the elements of object modeling technique 2.12. Question number at page number 45b. What we have got here, the analysis is the goal of the analysis is to develop the model of what system will do. You have to keep in mind the OMT only says what the system is gonna do. Express in terms of object and relationship, dynamic flow control, and the functional transformation. The processes of capturing requirements and consulting the requisitor should continue through the analysis is the object-oriented modeling technique. The data dictionary containing the description of classes, attributions, and associations adds associations between classes and add attributes for the links and objects. The object equals to object model diagram and data dictionary. To develop a dynamic model, we sometimes prepare a scenario of typical instruction sequences and identify some event flow diagram EFDs. And for system, the dynamic model is state diagram plus global event flow diagram. Construct a functional model, identify the inputs, and all blah blah blah. Many of the things is there. Now we are going to compare between the modeling technique with the SA and SD. This is important somehow. The structure analysis and structure design. This is one of the important things that several times asked in examination and all. So we are going to discuss the structure analysis and structure design. What is SA and SD is the representative of data flow approach. Most widely used in software engineering, methodologies are based on data flow diagrams, and OMT and SASD methodologies both incorporate similar modeling components. Both support three orthogonal views of system and dynamic function. Well, the summary of SA and SD approach can be like this. The variety of notation for formally specifying the softwares. It's a notation consists of set of notations which is used to specify some some softwares and its components, like data flow diagram, process specification, and data dictionary, state transition, ER relationship diagrams. They are used to logically describe some systems and softwares. That's it. A data flow diagram model are the transformation of data as flow through the system are the focus of SA and SD. Okay, one more thing is that the SA and SD, you mean structured analysis and structured design, they recursively divides complex processes into sub-diagrams. What they do, they recursively, you mean one by one, they divides the complex processes into sub-diagrams, small diagrams. There is nothing else. Turning over the page. Okay, we got some amazing things like JSD, Jackson Structure Diagram. What the Jackson, it was invented, or it was told by Michael Jackson. It was developed by Michael Jackson. It's a different styling technique, or distinguishes the analysis and design. It was only concerned with two words, how and what. What and how. What, how, what, how, what, how, what, how. Yeah. What is the specification and how the implementation to be done. Got it? Okay, I'm gonna tell you. If a software, the big software, we are deciding to create a big software. First of all, we think that what is software gonna do? That is the specification of that software. Yeah. And how the problem arises, that how it will do. That is the implementation of software. That's easy, man. Jackson told that. It's a big structure technique in which we only decide what and how. That's it. How it's gonna implement, and we think first that what it's gonna do. Easy. It divides the system development into two stages, that is specification and implementation. Like as I told before, specification means what it's gonna do, and implementation how it's gonna do. Easy. The JSD is intended especially for application in which the timing is important. It was specified for timing importance, and it is less graphically oriented like SA and SD and OMT, and it uses some graphical models, but it is less graphically oriented in comparison to SASD and OMTs. JSD model begins consideration of real world. It converts the real world problem into implementation of graphics, and then we are intent to develop the software. Easy. The JSD software development consists of 6 sequential steps. First of all, there is an entity action setup, an entity structure setup, initial models, function steps, system timing step, and then implementation. During the entity action the software developer lists the entities action for the parts of real world. Input to system, the requirement of system, and then output. They are the choice of entity action. And blah blah blah. There are lots of them. No need to understand. Okay, if we compare the JSD with OMT, then we get some different things. I'm gonna illustrate it. No JSD began with consideration of real world in the sense of object oriented, and rather the object models should have a rich mixture of data structure and relationship, as there is no data structure and relationship in JSD models. Due to its real-time approach, the heavy reliance or pseudocode are there. Heavy codes are there. Well, the JSD is complex compared to flow diagrams, data flow diagrams, and found necessary complex and simpler problem. It is generally used for complex problems, unlike the JSD is used for big problems like industrial types. We have an example of button and elevator. I don't want to waste the time over there. I don't think there is else here. Yeah, we got at page number 59b 2.18 the UML and what are its goals. Well, UML is generally a unified language, modeling language, has originally been developed to create models for softwares and systems. The word unified stands for the claim that language can be used for software in software system of a large number of different domains, from the business, economics, system and development, and standard software. Yeah, so much I've given in UML, like it's visual modeling language and captures the decision and understand about the system and must be constructed and used to understand, design, browse, configure, maintain, control information and about the system. Wow. Well, there is a goal of UML. I want to tell you. The basic unified modeling language UML are as follows. Basics of them are: provide models, ready to use expansive visual modeling language. It's expensive visual modeling language. Exchange of meaningful models. Provide extensively specialization mechanism to the extended core concepts. Formal basis of understanding the specification languages. Encourages the growth of object tool in markets. Supports high level of development with concepts of such as component framework or patterns. There are some rules of UML like name, scope, visibility, integrity and execution. There are some explanation of architecture of UML. There is a design view, implementation view, use case view in middle, and process view and deployment view. I don't think it's important. The structural things are UML are some class, interfaces, collaboration, use case, components, nodes, behavioral things, interactions, state machines, grouping things, packages, annotation things, and there are some relationships like dependency, association, generalization, realization. I don't think there is much more I have studied in this. So this was functional modeling from my side, Prem Kumar. Hope it's gonna be best. Oops. I don't think there is some more to describe in it. Okay, goodbye.